Hi, I'm Philip Yancey with BCI Technologies. This is a presentation on cellular, the paradigm shift that's transforming traditional licensed RF systems. BCI is a 31-year-old company based in Florida with 24 employees. We have always been focused on providing SCADA and telemetry solutions for the water and wastewater markets. We are the sole GE MDS Grid Solutions full-service partner for the Southeast U.S. Our products and services include telemetry solutions, instrumentation and controls, PLC programming, UL 508A control panel design builds, software development, and smart energy analysis and planning. Our goal is to exceed our customers' expectations, and our motto is we support what we sell. Today we're going to cover the benefits of cellular SCADA communications and show you how cellular will lower your communications costs while improving your system performance and reducing the amount of maintenance you're responsible for. Cellular actually costs a lot less. Cellular routers are literally half the price of a licensed radio. They require less infrastructure, there's no poles, lightning arresters, or coax jumpers to install, and cellular plans are only pennies per megabyte for today's utilities. Everything about a licensed system is expensive, and keeping this infrastructure in good working order is a full-time job. When cellular is used, the majority of the maintenance costs are shifted to the providers. Cellular has better performance. Legacy RF systems are generally narrow band and have a max throughput rated in serial baud speeds. As SCADA communications evolves into Ethernet, this bandwidth starts competing with protocols in network traffic. An example of this would be chatty protocols, TCP keep alives, and broadcast and multicast traffic. Cellular LTE systems support a wide range of speeds with an average of 5 through 12 and a maximum of 600 megabytes per second, making bandwidth no longer a concern. Think of cellular as having open and separate data highways for each remote in the field. Another way to think of it is having 100 lanes of traffic for 100 remotes versus having 100 remotes all using one lane in and one lane out. Cellular reduces maintenance simply because there's less to maintain. Licensed RF systems cost more because higher installation costs, which require more infrastructure like master towers, repeater towers, remote poles, coax, and lightning arresters. Licensed antennas because they're higher and more susceptible to lightning, wind, and water damage. Repairs can require climbing towers and boom trucks. Also, licensed 450 and 900 megahertz frequencies have been saturated for years, especially here in Florida, while ideal bands like 150 and 200 megahertz require long wait times or reoccurring costs from private owners. Licensed systems also require a clear line of sight to work properly. As its path degrades over time, signal strength is lost. It's important to understand that this is why RF systems are designed to account for losses. Losing only 3 dB of signal power cuts the total power in half, so minor losses can turn into huge problems. For example, if a building is built in a critical path, you may find the only way to resolve this is by increasing your antenna height or adding repeaters into the system. Compare this to cellular, where you may have a 200-foot tower every mile, making trees and buildings less of a concern. Here's an example of a typical RF system with a SCADA computer and master omni tower. As we add remotes, we're adding towers, coax, lightning arresters, and jumpers. The system requires line of sight, which you don't always have or may lose over time. As a result, problem sites develop with intermittent communications. Worse, if your master omni fails, the entire system is down until it can be repaired. You are solely responsible for system maintenance and recovery in the event of failures and outages of a traditional licensed system. With cellular, this burden is carried by the provider who has fail-safes in place to ensure a high level of reliability. The incredible demand for cellular services has driven the industry to dramatically improve the infrastructure. Cellular companies are investing heavily to meet this demand for not only cellular phones, but the Internet of Things, or IoT. Currently, there are over 10 billion mobile connections, which exceeds the number of people on the planet. As a result, prices have and will continue to drop. One of our cellular customers are paying about $4 to $5 per site per month. For them, the old cost of adjusting a Yagi now pays for that site's entire annual data plan. There's less infrastructure to maintain. There's no tall master or remote towers and antennas to maintain. Cellular antennas are usually inches high and mount directly to the panel. And should a cell tower go down, it's your provider's responsibility to fix it. Transparent redundancy. In most cases, remote sites can see more than one cellular tower and have transparent redundancy as a result. We'll speak more on this in a few slides. We should note that cellular providers offer 99.9999% reliability, which translates to about 32 seconds of downtime per year per service. Here in Florida, we've had customers continue operating during a hurricane with the only communication failures due to station power loss. We've had licensed customers be offline for a week until their lightning damaged Omni could be replaced. Not only was this critical infrastructure expensive to repair, but it also cost them additional employee overtime for manually monitoring 200 plus live stations while it was down. From 1983 to today, there have been over 154,000 cell towers built. By 2026, it is predicted that there will be over 800,000 towers in service. The best part of this is the cost of these towers is not in your capital improvement budget. Here is a typical cellular network. In this example, we are showing a SCADA PC connecting to a front-end router that's terminating a VPN into a private cellular network through an existing internet connection. This VPN tunnel provides secure access to a private APN network, connecting us to the end devices. Here we are also showing an example of built-in redundancy, as many remotes neighbor more than one tower. If a tower were to go down, the device would connect to the next strongest signal or tower available. Think of this like when roaming on a cell phone, and as you move locations, in most cases, you don't lose the call. The tower switching is usually seamless and transparent. Also note that a private network is a cellular network that is not internet routed. Cell tower equipment is privately owned, and when we mention a private network, we are talking about a cellular network designed specifically for you and to your specifications. This network is secure, private, and encrypted. The VPN termination at the SCADA server is creating an encrypted and secure tunnel for access into this private network. This is a secure and cost-effective approach. You don't have to have it all one way or another. You can go hybrid. In this example, we are showing a hybrid system that fixes our intermittent communication problem. Here you have a SCADA server and an existing RF system where we've added a front-end router with a VPN termination onto our private network. This method not only solves the original problem, but builds a foundation for future cellular networking, making remote additions or expansions very simple. This is exactly how one of our customers solved their intermittent communications problems due to RF interference. After converting only a few stations, the benefits of cellular became very clear, and they moved the remaining 600 stations off licensed onto cellular. But what if we don't want to get rid of our licensed network? Cellular can offer a cost-effective redundancy scheme. In this example, we show a SCADA server and an existing RF system with a front-end router and VPN termination into our private network. The primary path is the existing licensed radio system, which minimizes the usage costs. All data is routed through RF until the link is down or the network fails. The secondary path becomes active if the primary path fails. The traffic is then routed over the cellular private network. In this example, the remote devices require dual interfaces that support both the license and cellular. Many of our customers have already developed a licensed infrastructure at significant cost and may not want to abandon it. However, they may be upgrading, expanding, or just struggling with RF problems that require out-of-the-box thinking. Redundancy may solve this. Here's a few examples of Florida customers that have made the switch. Hillsborough County switched over 600 stations to cellular to get higher throughput while saving money. Lee County had 600 plus stations on an obsoleted Motorola trunking system. They selected cellular to get better performance at $4 to $5 per month per site. During Cat 4 Hurricane Irma in 2017, the cellular system remained functional. Their real problem were power outages. The city of Boca Raton switched to get a redundant system while also increasing remote capabilities. The city of West Palm Beach had the same need as Boca, where redundancy and additional functionality were important deciding factors. The city of Tallahassee went with a redundant system using a high-speed primary cellular path while keeping the RF network online for emergency backup communications. They also terminated cellular at the front end to ensure there was no internet accessibility to the SCADA network. So where do we go from here? First, you need to collect some basic information about your existing system. Things like SCADA, RTUs or PLCs, radios, switches, and protocols. Determine what is working well and what could work better or is not working at all. Think about future expansion and growth. Do you need to add or remove functionality? BCI has extensive experience with both the small and large systems and are here to help. This discovery phase is your first step to setting your expectations and to identify out-of-the-box solutions you might not have known were possible. The idea here is to get a basic understanding of your existing infrastructure to ensure the cellular architecture chosen will be the best path forward. What are the first steps into cellular? Once you have determined that you want to move forward with cellular, here are the basic steps. First, get started on a contract with a cellular provider, like Verizon or AT&T. They provide the engineering and design services for your network. There are a few factors that determine the cost of this service, but generally speaking, this step can cost anywhere between $500 and $5,000. We recommend getting a private APN, which ensures your cellular network is not on the internet. This usually takes a month or so. Once the network is designed and configured, you can purchase cellular routers and provision your devices using SIM cards from the provider. Provisioning is the process of assigning cellular service to a specific router. Really, it is the phone number and IP address assignment. Once provisioned, your cellular routers will automatically connect to the network when powered up. Install cellular router at the site and verify its connectivity. Modify your SCADA to now communicate using the new IP information. Just to summarize what we've covered today, cellular has lower costs and maintenance while providing higher performance. Cellular is getting more reliable and more affordable with better coverage. Adding cellular into an existing RF network can resolve problems immediately while laying a foundation for future cellular expansion. Architectures can include simple, hybrid, and redundant RF models. Using a private APN ensures your cellular network is private and not on the internet. Partnering with a cellular provider and solutions provider like BCI can make this transition a lot easier. We have over 20 years experience with RF. We look forward to helping you in this process. We are available for sales and support for all architecture types. In a nutshell, these are the major factors you should consider when deciding if cellular is right for you. BCI works with engineers, consultants, and end users to provide resources, support, and experience. Thank you for your time, and if you have any questions, please email us at sales@bcitech.com. I hope this has been beneficial for you, and thank you for watching.